Hello, Mr. Eicher here. This is part 2 of a lesson about recursive functions 9.0. We're going to look at two different shape sequences and see if we could write a recursive formula, a recursive function, or an explicit formula. So take a look at this pattern that we have here. And see if you could draw the next shape in the sequence. Pause the video if you'd like. So there's lots of different ways that you could think of this. There's many, many different ways. I guess what I noticed first is we have kind of a center and then one left, one right, one up. And then if we keep that center, now we go 2 right, 2 left, 2 up. And if we keep this center, we go 3 right, 3 left, 3 up. So I guess the next one would be 1 in the center. We'd go 4 instead of 3. 4 left. I'm going to shade in my center so I don't lose it. 4 left, 4 right, and 4 up. So that would be the next term in the sequence. Maybe another approach you did, maybe you counted how many there are. So it started with 4, then we have 2, 4, 6, then we have 7, and then we have 10. So it looks like how many are we adding each time? Well, on this first diagram we add all these guys to the old diagram. And then the next one we add all these guys. Kind of a cool shape there. Looks kind of like headphones or maybe a beanie. Yeah, I like the beanie idea. But each time we're adding 3. So for a recursive function, how would we write that? A recursive function, we're starting a recursive function for the total number of blocks in the pattern. So with the recursive function, you might remember we always have to start with how many we have. So our first term, we have 4 blocks. And then our next term, so any position after that, is the number of blocks we have before it. So that would be a sub n minus 1. And then we're adding 3. I'll even color code it for you since I wrote in green over there. So plus 3. So to clarify what this means, just to make sure you understand this notation. So this all by itself here would be our recursive function. But just to, again, to give you an example that you understand, we have what's our second term? How many blocks does our second pattern have? Well, that would be however many the first pattern, n minus 1, so 2 minus 1 is 1. How many our first pattern had plus 3? Our first pattern had 4, and then we're adding 3 to that, so our second pattern, a sub 2, should have 7 blocks, and it does have 7 blocks. Let's try again to make sure you understand the notation. Our third pattern, a sub 3, is our third pattern. That would be our second pattern, the one before it, plus 3. So our one before it, our second term, had 7, and then 3. So we have 10, and that's what we have, 10. So this is our recursive function. And I'm going to make that red now. Now this is only defined, I didn't mention this in the previous video, but I'll mention it now. This is only defined for n's that are greater than or equal to 1. So don't try to put a negative in here. If our starting point is 1, then we need n's greater than or equal to 1. And those n's are natural numbers, counting numbers, natural numbers. 1, 2, 3, 4, 5, 6. So we're not talking about decimals here. We're just talking about whole numbers greater than 0, which are called natural numbers. Okay, let's look at our next shape. Alright, so I'd like you to do 2 things. See if you can draw what the next shape will be in the sequence. And then see if you could start developing the idea of what a recursive function would look like. So pause this video and see if you could do that. So I got a shape like this. Kind of like the previous one, I noticed that we had a center block and then one in each direction, up, down, or how would you say that? One to the up on the left, one up and to the right, one down and to the left, one down and to the right. And then same thing, we had two, kind of like the previous pattern. Now instead of one, we have two. And then this pattern, we have three going in each direction. So for my pattern, I did 4 going in each direction. And then to write a recursive formula, recursive formula for the total number of blocks, we have 5. This one we had 2, 4, 6, 8, 9. This one we had 3, 3, 3, 12, 13. So it looks like our recursive formula is changing by 4 each time. So if we were to write our recursive formula, we write where we start. Our first term has 5. And then our next term, or any ath term that we want, we're going to take the term before it, a sub n minus 1, and we're going to add 4 to that. So what that would look like as an example, so pretty sure that is going to work, so I'm going to box that. As an example, if you want your excuse me, your second term, you're going to take your first term plus 4. So your second term would be, your first term was 5, you're going to add 4 to that, and you get 9. And that's what we should get, 9 total squares. And let's do one more. If you want to find your third term would be your second term plus 4. Your second term is 9 plus 4. So your third term would be 13. There are 13 boxes. So this is looking at recursive functions a little more artistically. I really like that square that I made there. It's kind of sly, kind of like that. But this is looking at recursive formulas, getting you used to the notation for recursive formulas. And I just want to end so I don't forget, again, this recursive formula is only defined when n is greater than or equal to 1. So don't try to put 0 into this because it starts at 1, so you got to start at 1. You can't put negative numbers in or 0 in. And these are only whole numbers. They're only whole numbers, or natural numbers, I should say, because we're counting terms, 1, 2, 3, 4, 5. We can't have decimal or fractional terms. Thank you for watching this video. Have a great day.